Have you ever wondered what it takes to pass one of the world's absolute toughest exams? Well, today we're going deep inside India's Joint Entrance Examination Advanced, or as it's known, the JEE Advanced. And we're going to do it by looking at just one topic that perfectly captures why this test is such a massive challenge: fluid mechanics. Okay, let's get into it.
To really get a sense of the scale here, let's just start with a number. In 2024, this is how many of India's brightest students sat for the JEE Advanced. But here's the thing, every single one of them had already passed another huge exam, the JEE Main, just to earn the right to be there.
And out of that incredibly talented pool, this is the number that actually qualified. That's less than 27%. The competition is just staggering, right from the get-go. So what exactly is this exam that everyone's talking about?
Well, the JEE Advanced is the one and only gateway for getting into the legendary Indian Institutes of Technology, the IITs. For decades, this exam has been the gold standard for academic excellence in science and engineering in the entire country.
And the challenge is just immense. We're talking about a 6-hour marathon split into 2 3-hour papers all on the same day. And it's not about what you can memorize. Nope. This exam is built from the ground up to test how you apply fundamental ideas to solve really complex problems you've probably never seen before. It is pure and simple a test of how you think.
So to really understand how this works, we're going to zoom in on one subject from the physics syllabus that seems pretty simple on the surface, but it is incredibly deep: fluid mechanics.
At its heart, it's basically the science of stuff that flows. From the water in your tap to the air that moves over an airplane's wing. It sounds pretty straightforward, right? But the rules that govern all that flow are, they're incredibly nuanced.
And this stuff is literally everywhere. Fluid mechanics is what helps us predict the weather, it lets us design airplanes and ships, and it even helps us understand how blood flows through our own bodies. Its applications are just massive, which is why mastering it is so important for any future engineer.
All right, so let's get into the core physics that these students have to master. What are the fundamental rules that tell a fluid how to behave?
It seems like such a basic question, doesn't it? But the answer is surprisingly complex. See, fluids don't just move in one simple way. Their behavior can be super orderly and predictable, or it can be completely chaotic. So there are 2 main types of flow. Think of streamline or laminar flow, like cars moving perfectly in their lanes on a highway. Every little particle just follows the one in front of it, nice and smooth. But turbulent flow? That's a chaotic traffic jam with cars swerving all over the place. It's erratic, messy, and there's a ton of mixing going on.
So how in the world do scientists predict which type of flow is going to happen? They use this, the Reynolds number. It's this awesome value that boils down all the complicated stuff, like a fluid's density, its speed, its viscosity, into one single clean number. And that number is the key to everything.
And these are the magic thresholds. A low Reynolds number means you get that smooth laminar flow. A high one means you get turbulence. But see that tricky unsteady zone right in the middle? That's where it gets really interesting. And you better believe that understanding that subtle difference was the key to a notoriously difficult question on the 2021 GE exam.
Okay, so knowing the theory is one thing, but how does the exam actually force students to use it when the clock is ticking? Let's break down a classic problem. This looks so harmless, doesn't it? It's something we see every single day. Water falls from a faucet, and the stream gets thinner. The question is, can you calculate exactly how much thinner? This is where it gets tricky, because this is not a one-step problem. And here's the secret sauce. This isn't just a fluid dynamics problem. You have to connect 2 totally separate ideas in physics. First, you have to use basic kinematics, the physics of falling objects, to figure out how much gravity speeds the water up. And only then can you use your fluid dynamics knowledge to find the new diameter.
And this right here is that second principle, the equation of continuity. It is such a beautiful and simple idea. All it says is that the area of the flow times the velocity at one point has to equal the area times the velocity at some other point. So as gravity makes the water speed up, making V2 bigger, the area of the stream, A2, has to get smaller. That's it. That's why the stream narrows.
And solving problems just like that one, connecting all those dots in just a matter of minutes, is exactly why the prep for this exam is so unbelievably intense. It's not about just studying, it's about training your brain to see these connections instinctively.
So all of this brings us to a much bigger question: why? Why design a test that is so incredibly demanding? What is the ultimate goal of putting students through all of this?
The whole point of the JEE Advanced was never just to find the students who could memorize the most formulas. It's about finding and growing the minds that will become the next generation of great engineers and scientists. People who can take fundamental principles and use them to solve brand new problems.
And that really gets to the heart of it, doesn't it? The exam pushes students way beyond just knowing an equation. It demands that they understand the physical reality behind it all, that beautiful, complex, and sometimes chaotic dance of fluids that literally shapes the world around us. And that is the real test.